Test hypotheses about a population proportion. Our objective, we want to test hypotheses about a population proportion. Go figure. Let's remind ourselves a couple of things that we already know that will come into play here. We know that the sample proportion p hat is used to estimate the population proportion p. If it's not provided, if you don't know the sample p, if you don't know p hat, the sample proportion p hat is calculated as x over n, where x is the number of individuals in the sample with the specified characteristic, and n is the sample size. We also know that if we have n times p times 1 minus p greater than or equal to 10, and that the sample size is less than or equal to 5% of the population size, then the sampling distribution of p hat is approximately normal, with mean p and standard deviation square root of p times 1 minus p over n. Okay? So what are the steps for testing a hypothesis about a population proportion? Well, we'll begin with, is it normal? Okay, are the conditions above satisfied? And these are our two conditions, np times 1 minus p greater than or equal to 10, and little n is less than or equal to 5% of the population size. And since we're assuming our null hypothesis p is equal to p sub 0, we're assuming that's true, we're going to use p sub 0 in place of p here instead to test that condition. Okay, conditions are satisfied. Move to number 2. Determine the null and the alternative hypotheses, two-tailed, left-tailed, or right-tailed, and we've been through this. Notice that we are using p sub 0 as the assumed value of the population proportion determined by the problem. Okay, step 3, determine the level of significance alpha, which depends on the seriousness of making a type 1 error. A type 1 error is when we reject the null hypothesis, when in fact the null hypothesis is true. We'll be given that. We'll be given the level of significance we're looking for. All right. Step 4, use StatCrunch to calculate the p-value. For proportions, we deal with stat, proportion stats, one sample, and with summary, the data we're dealing with when we're dealing with proportions are always summarized. Step 5, determine whether or not it's unusual. It's unusual with a p-value test if the p-value is less than alpha. If it's unusual, we reject the null hypothesis. Again, unusual means the p-value is less than the level of significance, which is alpha. And as a reminder, the cute little phrase we have, if the p-value is low, the null must go. And step 6, we state the conclusion in the words of the problem. If we reject the null, we say, with an alpha level of significance, whatever alpha is, there is enough evidence that the alternative hypothesis is true, but we're going to use the words of the problem. If we fail to reject the null, we will say with an alpha level of significance, again, using whatever alpha is, there is not enough evidence that the alternative hypothesis is true, again, written in the words of the problem. Okay? A lot there. Let's go through a couple of examples. One will be using the p-value, and one will use the confidence interval. So give me a second here to get my stuff together. All right, and keep my StatCrunch open over here. Okay. In 1997, 46% of Americans said that they did not trust the media, quote, to report the news fully, accurately, and fairly, unquote. In a 2007 poll of 1,010 adults nationwide, 525 stated they did not trust the media. At the alpha equals 0.05 level of significance, is there evidence to support the claim that the percentage of Americans that do not trust the media to report fully and accurately has increased since 1997? Okay, number one, we're going to check our conditions. Okay, well, our first condition, N P naught, P sub 0, which is here, which is 0.46. Okay. Times 1 minus P sub 0, well, that's equal to 525 is, let's see here, our sample size. Our sample size is not 525, our sample size is 1,010 times 0.46 times 1 minus 0.46, and give me just a moment, as I think I calculated the wrong value. So I'm going to calculate this for us. 1,010 times 0.46 times 1 minus 0.46. And we come up with 250. I'll go to the 100th, 0.88. Well, that is certainly larger than or equal to 10, so that condition is good. Our second condition is good. Is 1,010 adults less than 5% of all U.S. adults? And yes, 1,010 adults is less than 5% of U.S. adults. Okay, our conditions are met. We can move forward. Step 2 are null and our null and our alternative hypotheses. Well, our null hypothesis is always our hypothesis of equivalence, and it says that P is equal to 0.46. Our alternative hypothesis has it increased? So we want to do a right-tailed test. Is it greater than 0.46? Step 3, determine our level of significance. Well, we're told that alpha is 0.05. That's right here. And obviously we're looking for a 95% confidence. Okay, how serious we want this to be. Okay, step 4, let's go into StatCrunch and come up with our p-value. Okay, let's go into StatCrunch here. I'll get it down for us, make sure it's in there fairly. Yeah, I think I've got ourselves fairly straightened out here. Okay, so we're doing proportion stats. We're doing one sample, we're doing with summary, and here it is. And we're performing a hypothesis test. Notice it's already, that's the default. How many successes? Well, let's see, we had 525 successes. How many observations? There were 1,010 of those. Okay, and we wanted to be, yes, we wanted, no, we didn't want this, we need to change this. We want it to be our null hypothesis, P equals 0.46. So we got to change this to 0.46, and our alternative is not equal to. We need to select the right-sided test, the right tail, which is greater than, and you see it fills it in for you right there. And now we can compute. And I want you to notice a couple of things. I want you to notice the z-stat. I'm going to write that down because sometimes your MyLab problems will ask you for the z-stat. And I'm going to make a note here. The z-stat is 3.813. Okay, z-stat. But we're looking for the p-value. Well, the p-value says this p-value is less than 0.0001. That's a mighty small p-value. And as we know from our phrase, if the p-value is low, the null must go. That is a very small p-value. Okay, also notice here that it did the math for us for the sample proportion. It took 525 and divided it by 1010. And so p hat is equal to 0.520 to 3 decimal places. Okay, so we've got that. Give me a moment again to get myself set up here, and let's make some notes of what we found there. Okay, we came up with a p-value of less than 0.0001. Oh my goodness, that's small. But again, let's also note the z-stat, which is sometimes z-naught, is equal to 3.813. I'm just noting this because sometimes that will pop up in your homework. We're not making use of the z-table, but that's the z-stat that you can fill into that blank. Okay, so step 5, unusual, right? Well, unusual is, let's write this down. Unusual, in this case, we want p-value less than alpha. Well, our p-value is smaller than 0.0001. Our alpha is 0.05. You can see it right here. So yes, unusual. Okay, it's far, far less. Okay, so 6, let us state our conclusion. Okay. If the p-value is low, the null must go. All right, start it off this way. With a 0.05 level of significance, there is enough evidence to support the claim. Remember, we're always going to talk about it from the alternative hypothesis, okay, that the percent of Americans, the percent of Americans that do not trust the media, and I'll leave that there as opposed to rewriting fully and accurately, has increased since 1997. Okay, so a brief recap here. We checked our conditions to make sure we can move forward. We stated our null hypothesis, which is always a hypothesis of equality. In this case, our alternative hypothesis was a greater than or a right-tailed hypothesis. We stated our significance level, which was, we wrote it down, it was given to us in the problem. We went to StatCrunch and calculated the p-value, which is really, really tiny. The p-value test says if the p-value is less than the level of significance, it's unusual. Well, this p-value, which is almost 0, is well less than the level of significance, 0.05, 95% confidence. So we say it's unusual. And so therefore we say, with a 0.05 level of significance, there is enough evidence to support the claim that the percent of Americans that do not trust the media has increased since 1997, which is what our alternative hypothesis was. We always write our conclusion using the alternative hypothesis. Okay, let's do an example with the confidence interval. And again, give me just a moment here to get myself organized. Okay, I think I'm here. Let's see how I do. All right. Okay. A 2009 study by Princeton Survey Research Associates International, that's quite a title, found that 34% of teenagers text while driving. Does a recent survey conducted by Consumer Reports, obviously a recent survey is more recently than 2009, which found that 353 out of 1,200 randomly selected teens had texted while driving, suggests that the proportion of teens who text while driving has changed since 2009. Use a 95% confidence interval to answer the question. Okay. Number one, let's check our conditions. NP times 1 minus P. Okay, that's equal to, well, our P is 34%. It's going to be, so it's 0.34 up here. Our survey size is 1,200. So is 1,200 times 0.34 times 1 minus 0.34. Well, first off, what is it? And this one I did the math on. I hope I did it correctly. I got approximately 269.28 to 2 decimal places. That is certainly greater than or equal to 10. So that condition is met. And is 1,200 less than 5% of all teens? I think we can say that 1,200 teens is less than 5% of all teens. So check. All right, number 2. Let's state down our null hypothesis and our alternative hypothesis. Our null is a statement of equality. Our null says the proportion of teenagers who text while driving is 0.34. So our alternative, this one has changed. So that means it's different than. So we'll use the not equals to symbol. Has changed can be greater than or less than. So it's simply not equal to. Notice we have to have a not equal to alternative if we're going to use the confidence interval test. Okay, step 3, level of significance is not applicable because this is a confidence interval test. I do want to note that 35, that P hat, I guess, P hat is equal to 353 out of 1,200. So our P hat is approximately to 3 decimal places, 0.294. We're going to see StatCrunch do that for us as well. Okay, let's go into StatCrunch this time, and we're going to make use of the confidence interval test as opposed to the p-test, the p-value test. So we'll go back into StatCrunch. Okay, we're going to go again back. We'll go back to stat, proportion stats, 1 sample with summary. So I've gone into stats, proportion stat menu, proportion stats, 1 sample with summary. Okay, number of successes. Well, we had 353 teens who were texting while driving. Number of observations, we're talking 1,200. And this time we're going to perform a confidence interval for P. So we're going to select that option there. We want to have a 95% confidence level. Well, the default is good. Okay, and then let's go ahead and press compute. Okay, unless I think I can make that larger, I sure can. Let's notice our sample proportion. We calculated ours is 0.294 p hat, and that's calculated here for us. Okay, and we're going to notice that our lower limit to 3 decimal places is 0.268, and our upper limit of our 95% confidence interval is 0.320 to 3 decimal places. Okay, so there we have it. So now let's come back to our sheet. We can answer the question. Continue to answer the question, I guess I should say. Okay, so our 95% confidence interval has a lower limit equal to 0.268, and I usually like to put a 0 in there, and an upper limit equal to 0.320. And as a reminder, we calculated p hat as 0.294. StatCrunch did the same. And now let's take a look. Is this unusual? Okay. Is this unusual? Unusual. Well, unusual means outside of interval. Okay, that's what unusual is. Is it outside of the interval? Well, no. 0.294 is not outside of this interval. Okay, no. 0.294 is not outside of our confidence interval from 0.268 to 0.320. So it is not unusual. Okay, well, if it's not unusual, we can say that we are, nothing has changed. We are not rejecting the null. So, because 0.294 is within the confidence interval, there is not significant evidence to conclude that the proportion of teens who text while driving has changed since 2009. Okay, let's recap this one. Okay, we checked our conditions. We stated our null hypothesis and our alternative hypothesis. This is not a p-test, this is an interval test, confidence interval, so we're not concerned about it. We don't have a level of significance. Okay, we did note that when we calculated our p-hat, we got 0.294. We went into StatCrunch and put in a 95% confidence interval. We came up with a lower limit of 268 and an upper limit of 320. Unusual means not in the confidence interval. Well, this is clearly inside of this, so it is not unusual. Therefore, we fail to reject the null. Our conclusion is from this standpoint. We always speak to it from the alternative. So there is not enough evidence to claim that the alternative is true. Not enough evidence to conclude that the proportion of teens who text while driving has changed since 2009. A quick recap of these two methods about a population proportion. The p-value approach, one-tailed or two-tailed. The strengths, it provides a measure of significance, that's our p-value. The weakness, it does not provide an estimated range of values for the parameter. The opposite is true for the confidence intervals method, which is for two-tailed tests only. It provides its strengths. It does provide an estimated range of values for the parameter, but it does not provide a measure of significance.